So in this video, we're going to talk about the dot product of two vectors. So given, let's say we have a vector u and it's x1 plus y1. In column vector notation, it's x1, y1. Let's say we have a vector v. Let's say we have a vector v, x2 plus y2. So column vector notation x2, y2. Yeah. So the dot product u dot v is given as such. So you have x1 plus just give me 1 sec. Yeah, the dot product is given as such. So we multiply the corresponding x components of each of we multiply the corresponding components, the x components of each of our given vectors. So we say x1 by x2, and we add it to the product of the corresponding y components of each of our vectors. So y1 dot y2. So this is the dot product. Let's see this with some numbers here. So let's say I have vector u to be 2, 3, and vector v to be, for the arrows, most of the time I store the arrows, but it's understood to be there, or any other notation for a vector. Let's say here's 5 and 3, so u dot v is equals to, well, 2 by 5 plus multiply the corresponding y's now, 3 by 3, so we have u dot v is also equals to 10 plus 9, so we have the dot product being equals 19. Now there is a geometric or graphical interpretation of the dot product, but that is beyond the scope of CSEC, and if I'm recalling correctly, even beyond the scope of CAPE. But when I finish with the CSEC and CAPE videos, and I start my tertiary videos, I will show you guys the actual geometric, or what the dot product actually does. You guys just have to know how to calculate the dot product. Now, this is how you calculate the dot product. Now, an application of the dot product is as such. So yes, as you guys know, paint is the best, and my inspiration, Sal Khan from Khan Academy, he always uses paint. Just paint this block again. Right, so there's a formula that says cosine theta is equals to u dot v all over the norm of u by the norm of v. Now, this formula here allows us to find the angle between two vectors. Let's see how to use this. So let's say I have u to be 2 and 3 and v to be I think 5 and 3. I'm trying to keep the vectors consistent throughout the examples. I'm just making these things off the top of my head. Well, the numbers. So the formula u dot v, well, it would be 2 by 5 plus 3 by 3. Okay, yeah, it was the same vectors from the previous example. So 10 plus 9 is 19. So we have u dot v is 19. Now the length of u, well, that's the square root of 2 squared plus 3 squared, which is equals to the root 9 plus 4 is 13. I will leave it as suits because I don't have a calculator. I'm just showing you guys the technique. Plug it in the calculator as you see it and you will get the answer. But when you're doing these things, don't round off. Leave it as a suit before you plug it in a calculator. And well, let's work the norm slash length slash size slash magnitude of a vector here now for v. So we do the same thing. 5 squared is 25 plus 9. So we have the norm of v is the root of 25 plus 9 is 34. So both of these things, leave it as suits when you enter it into this formula. So now we could see cosine of theta is equals, well, u dot v was just 19 all over, well, the length of u, the norm of u, the magnitude of u was root 13, and the norm of v, the length of v, or the magnitude of v. I'm using the words to instill it in your heads, the different terms they would use to refer to the same thing. The magnitude was root 34. Alright, that's a square root there, close enough. So normal tricks now, theta, so I say theta is equals to the cos inverse of everything here. So 19. For those of you all who have the fractional view on other calculators, this is be a cakewalk. For those of you all who do not have a calculator with fractional view, get one. Especially if you're doing ADDMATHS, get one. It does integration, differentiation, everything you need to do in ADDMATHS, it does it. So you can at least see what your answer is supposed to be. That's a big advantage. And enter this in your calculator and you will get your answer for the angle between two vectors, u and v. Done. So in the next video, I want to start limits. Well, no, sorry, differentiation.